How's it going, everybody?
Good.
Pretty
A
good.
lot of you missing today.
Yeah, they're sick.
It's okay. Weren't you sick? Did you get them sick?
Yeah. But I'm back.
Oh, Connor. You're not supposed to come to school if you're sick, man. Because now they're missing out on lessons. It's all good, though. It's all good.
It's all willpower.
It's all willpower. Exactly. Vitamin C and willpower, right?
Yeah.
Alright, you're in algebra class, obviously. Thank you again for being here. John, you want to read the first learning target for us, please?
Yeah. I will be able to estimate a graph line based on function.
A function. Good catch. So I work together and say them together. Based on a function. Connor, the second one.
I will be able to look at a graph and estimate what the function might look like.
Exactly. Not even might look like. We're going to figure out what the function will look like. You guys are going to be so good at it today because you're doing a mini project.
Oh.
It won't take that long. Don't stress about it. So what you're going to do is you're going to pick any of these graphs. Notice I left linear off of there because it's too easy. I don't want you guys challenging yourself. You're going to manipulate the graph and the function for it, which I've written above each of them. You're going to manipulate it, and then you're going to come up here and draw it, and you're going to give me a real world example of the equation that you used. You guys understand?
Mm-hmm.
So step one is going to be picking a function. I'd like each of you to do a different one, please. You're going to manipulate the function. You're going to draw the graph and give me an example of how that graph might be used in the real world. If you need help for ideas of how it might be used in the real world or anything like that, just let me know and I can help you guys out. But we did go over examples the other day, so ideally you'll have a few in mind. So go ahead and get started, pull some paper out, calculator, whatever you guys might need, and go ahead and start working on that. Need a piece of paper, man?
Yeah.
Alright. Some black paper right here for you. And I'll be walking around and seeing how you guys are doing. And make sure you're communicating on which one you guys are doing so you're not doing the same one.
Okay,
Which one are you doing, John?
Y equals x to the third.
Nice. That's a tough one. Connor, which one are you doing?
Y equals x squared.
Perfect. So those ones are pretty basic ones. You should be able to knock this out of the park. Alright, John, you think you might be able to come up and show me what you got?
Yeah.
Okay. I'll even let you pick whatever color you want. Blue, green, red.
Pink.
No pink.
Yeah, green.
Oh, we also have brown. Alright, so just in that space right there, yep, just go ahead and draw a graph. Make sure you put your axes. And then the graph you got, and then the manipulation you have on the equation.
So.
Don't worry about numbers, we're just going to just give us a general idea. Or give us the numbers that we need at least.
So the function that I came up with was y equals x minus 3 parentheses to the third, and then minus 3.
Okay.
So like that.
Alright, you want to write your equation in big old letters over here so we can all look at it? And this is a 2 right here. Redraw that so I don't get confused. Alright, you go ahead and sit down real quick. Alright, John, so we had x minus 2 to the third minus 3. Connor, does that look like it's right?
Mm-hmm.
That's exactly right. Good job. Now, how do we use that equation in the real world? It's a tough one for this equation.
Not entirely sure.
let's say we add well, decay in chemistry is always a good example. So let's say we add jonathinium is a chemical compound that decays by 2, or its half-life is 2, but it's got a weird half-life, so it happens every 3 years. Decays by 2 atoms every 3 years, okay? So that's what this is gonna look like, and then the -3 is, we already lost 3 atoms. We're counting after the 3 atoms have already been lost, okay? So that's real world, but not really. Also, that's not decay, that's growth. So we have a bacteria called jonathinium, and it grows at the rate we said. All right, Con, what do you got for us, bud?
Well, I did the y equals x to the second power.
Okay.
You don't want numbers, right? Just a general idea.
Just the numbers we need to figure it out.
Okay. So I did. Go thing. I'll go there. See if I can do this. Sorry, I'm not an artist.
You're okay. All right, then you want to write our equation right there too. Connor's got the fancy lines that curl. When I was in school, this is a long time ago. What, 8, 9 years ago when I was your guys' age? My teacher would mark us down if we didn't do cursive X's and Y's. So that's why I write in the way I do. But you guys don't have to. I won't be like that to you guys, but more just an observation. All right, Connor, what equation did we have?
So I did y equals parentheses x minus 3 to the second power plus 4, and so it'll cross at the 4 mark on the y-axis, and then it's over 3.
How's that look?
Right.
Think something's wrong
No,
with
yeah,
it?
yeah, that's right, that's right.
Is it?
Pretty sure.
You were super close. So you're thinking linearly, which is understandable because that's one we know really well, right? So when you have a parabola like that, it's not going to cross, the B is not where it crosses the y-axis. And I know that sounds weird, but since it's a parabola,
Oh,
it's
yeah.
where the origin increases. So if you have -3, your start was right, but this is going to come up at +4. Is where the vertex is. That's what the bottom of a parabola is called, where it zeroes out, where the slope is 0. It's a derivative we'll learn about in a few years. But that's what it would look like. You were super close though, and that's what a lot of people think, so don't stress about it. All right. And we won't do a real world example because as we found out, those ones can be kind of hard.
And I was sick.
So, as you guys know, because we learned yesterday, that's how magnitudes are how we change all these functions. These are just a few of the parent functions. So, if I had a number bigger than 2 here, it would be sharper. If I had 2 to the x plus 1, it'd be moved left. If I had 2 to the x plus 1 on the outside, it'd be moved up or down. That's how it's going to work for every single one of these functions. So I'm going to draw a function and you guys are going to guess what the equation is going to look like, okay? You guys feel confident?
Oh yeah.
You guys feel ready?
Yeah.
So, let's do, just raise your hand when you think you know it. Whoever gets more points, I'll even give a bonus point in the next quiz. You guys know this one, it looks just like one of them up there. Yes,
take a
Connor.
stab at it. Is it the y equals log x?
Okay, but if I manipulated it, what would the
Oh.
equation look like?
It'd be,
John,
Y equals log x plus 2.
where does the plus 2 go, with the x or without the x?
Without the x.
Yes, that's exactly right. So it'll look something like y equals log x plus 2. That one's kind of hard to write. That's probably the easiest way, is just use parentheses. Alright, try another one. Let's do, this is a little bit trickier. This one's kind of hard to pinpoint with your eye, but a good amount of numbers will work for this one. As long as I get what you guys are going for, you'll be alright.
Is this one, y equals 3 over x.
Sure. Y equals 3 over x sound. Not quite.
Could
Flip
you
it.
explain that one?
Yes, but hold on. Move the 3.
Y equals 3x?
Y equals 1 over 3x.
Oh, okay, I see.
So, because we know about fractions, oh, I'm sorry, Connie, you wanted me to explain that one. So we know about fractions, as the bottom number gets bigger, the whole number gets smaller, right?
Mm-hmm.
So if we had 3 over x, it looks something more like that. I mean, that's a really bad drawing, but. So Connor, that's exactly what we're saying. So as this number gets smaller, so imagine we had 1/2 over x, which is the same thing as 2x, it gets really big. If we had like 0.0001 over x, that's the same thing as 10,000x, because you know how fractions work, right? So that's why this number is so tall. Now, if we just have this, we do 1 over 1, it's just 1, right? But if we do 1 over 4, it's going to be smaller and therefore closer to the y-axis. So that's why this one's a lot tighter. Let's do one more, and then we're going to work on you guys' KWO charts and call it a day. Huh. How can I get you guys? Oh my god. Oh look.
Don't look.
You guys know how to do this one. Think really hard about what you know about
Y
graphs.
equals negative x to the third.
Yes.
Plus
Want to throw in a little bit more for me?
4.
Sure. That sounds good to me. How did you know that, John?
Well, it's the inverse of y equals x to the third. So to make the inverse, you just add a negative sign.
Can you add one more thing in there for me to make it look more like what the graph looks like?
It's a little bit more slanted, so it's y equals negative 1/2x. Right?
Yes. Sorry, you're right. I was thinking the other way. Yep. So we'd have something like y equals negative 1/2x, because it's a little bit wider, right? The easy way to show that is if we did the exact same thing, instead of a third, we had a half. It would look like be a little bit wider like that. So, good job. You guys nailed it. That was perfect. Remember, we do have a test tomorrow on this unit. Don't stress about it though. You guys know how to do all this stuff. It'll be over parent functions. We're going to talk about manipulating graphs. It's going to be a combination of you guys manipulating graphs and you guys looking at manipulated graphs and figuring out what they are. So, you guys have KWL charts we filled out at the beginning of the unit. Of course, you know that stands for what we know, what we want to know, and what we learned. So bust those out. You guys did them about a week ago, and we're going to look at them, and there's a ton of stuff that's going to be on the what you wanted to know line that you already learned. So Connor, what was one thing that was in the W that is now in the L? Something you wanted to learn that you now know.
I wanted to learn how to manipulate functions.
And you got that, right?
Mhm.
Sweet. John, do you think we completed our learning objectives for the unit?
Yes.
Do you think you're able to estimate a graph line based on a function?
Mhm.
Well, because we already did that, right? Connor, how about the second one? Do you think we were able to look at a graph and estimate what the function might look like?
Mhm.
Because we just did that. Alright, you guys are all set. I would like to take your KWL charts on your way out. If you can put them on the front desk, I would appreciate it. You guys go enjoy lunch, and I'll see you tomorrow for our test. Make sure you bring a calculator too.